Hi, welcome to listen to Erlab lecture. This now we're going to talk about one of the very popular model from Erlab filtration ecosystems, which is the Halo laboratory air filtration systems, a ceiling mounted filtration systems. It is designed to work 24/7 non-stop to remove fugitive emissions or VOCs or the odors from your laboratory. It's equipped with a laboratory-grade filtrations, carbon filters. Erlab claimed that the Neutrodyne technology can have a longer shelf life, basically double the capacities for the normal carbon filters. Halo is low cost because it's not linked to HVAC. There's no ductwork required. It's very low energy consumptions, just 50 watts. It is actually lower than the lamp that you use in your house. It's easy to set up and simple operations. There are 4 types of Halo systems. It is different in terms of the carbon that they use and also the detection system used in this system. The first models is for VOC, to remove VOC from the room. It has the VOC detectors and the carbon filters that are designed to absorb VOC. The second is what we call Chem Plus. It's meant to be used in a room that contaminated with solvents. The filters is optimized for solvent remover. The third model is for acids, vapors. Sensors and the filters are designed to remove acids as a primary and solvent as a secondary. The last one is for hospitals and for museums to remove formaldehyde, to constantly absorb and remove the formaldehyde. So what Halo laboratory air filtration is not? It is not a clean room authorized HEPA filters modules. Even though from the appearance it looks more or less the same, but the principal mechanism are different. So HEPA filter modules basically produce clean air. It is used for in the ISO 5 class clean room, whereas Halo laboratory air filtration systems is not generating positive airflows. It's basically suck the air from the room, filters and return the air back to the room. Halo laboratory air filtration system is also not a HVAC system, and it is not a ducted air change systems. You can see these ducted air change systems basically to improve the air change in the factories. So Halo laboratory air filtration systems have at least 4 main functions. Number 1, it improves the air change rate in the laboratory. Number 2, it absorbs, filtered, and then remove the chemical vapors from the air. Number 3, it provides alerts to users when it detected the fugitive chemicals emissions present in the room. Number 4, to provide seamless, smart, and continuous supply of purified air into your laboratory. Let us examine this function one by one. First, to improve air change rate in the laboratory, as you can see from these international standards, ASHRAE, OSHA, and NFPA, the recommended air change for any laboratories is at least 4 up to 12 air change per hour. So how do we calculate air change rate? So you can calculate the air change rate by getting these informations, the Q divided by the V. The Q stands for process airflow, where you can get from the specifications of the Halo systems. It's specified that the fan can process up to 220 cubic meters per hour of airflow. Then we obtain the volume of the room. Erlab claimed that one Halo is optimized for a room areas of 20 square meters or a volume of 60 cubic meters. Let's say we have a room of 20 square meters and the typical laboratory height is around 2.5 meters to 3 meters. If you multiply 20 square meters with 2.5 or even 3 meters, so you can get a room volume of 50 to 60 cubic meters. So let us calculate the air change per hour. So the Q here is 220 cubic meter per hour. Divide by a typical room volume of 20 square meter, multiplied by 2.7 meter height, you can get around 55 cubic meters. So 220 divided by 55, it will be 4 air change per hour. That is how we calculate the air change rate. One thing we need to emphasize here, Halo air filtration system is designed as a secondary containment. The emphasis still go to a primary containment. Example for primary containment is fume hood and the chemical storage cabinet, because the vapors is generated inside this hood. Halo is designed for secondary containment when there is a release of escape of these vapors into the room. Halo will be used to further remove these odors or VOCs. This is a typical examples of where Halo been used in the laboratory. You will see there's a primary containment, the fume hoods, and Halo serve as a secondary containment to further remove the vapors from the room, so the room has a better air qualities and the people working inside are more comfortable. Number 2, to absorb, filter, and then remove the chemical vapors from the laboratory air. So the typical halos are equipped with these features. We'll go from the upper right, the air outlet of purified air. So the air being filtered by the carbon filters will be released from this air outlet. And then you will see a chemical sensors. Each units come with chemical sensors. If you have a VOC filters, then it will equip with a VOC chemical sensors. If you have a formaldehyde carbon filters, then you will have a formaldehyde sensors together in your halo. Then the air is sucking in from the air inlets with a pre-filters. Then above the pre-filters, you will have a 10 kilos of Neutrodyne carbon filters to remove and absorb filtered the vapors. Following with the halo alert LED lights. So when the room air qualities are okay, the halo light will be constant. Once it detected the fugitive emissions, so this LED light will start to blink to alert the user there is a presence of vapors or chemicals in the room. Lastly, above the ceilings, there will be routers, wiring, mounting bracket, and sockets. So here is how the air been sucked into the halo systems, and then the purified air will be released back to the room. So it's 4 air change per hour. So the following video shows how the carbon filters works. I think we have to differentiate HEPA filters with the carbon filters. HEPA filters are used to filter off powders. The typical size for powders is 1 micron to 3 micron and above. But carbon filters are dealing with molecular gas vapors. So it's dealing with 10 nanometers to 1 nanometer size of gas molecules. Erlab Neutrodyne carbon filters are optimized with the highest affinities, the active surface areas of over 1000 square meters per 1 gram. Number 3, to provide alerts to users when detected the fugitive chemicals emissions. So the typical halos will function as follows. So the fan will constantly run at 1 speed at the normal room conditions, where the air qualities are below the threshold limits. The sensors constantly monitor the room air qualities. So when the sensor detected the fugitive emissions and exceeded the threshold limits, what will happen is the fan speed will ramp up to 2600 to 2800 RPM to increase the air change rate, to remove the fugitive emission as quickly as possible. Then what happened? The halo LED will be triggered and it will start to blink. So the user will be alert and know that the fugitive emissions happened in the room. So the software will show and display the air quality via handphone or via your laptop. This is typical how it looks like when the halo detected the fugitive emissions that exceeded the threshold limits. They will start to blink, and you can hear the fan's noise is louder because it starts to ramp up to a higher speed. Number 4, to provide seamless, smart and continuous supply of purified air into your laboratory. So it's seamless and smart because each halo systems come with the software where you can use to monitor the room air qualities. So to ensure that the air is constantly supplied with the purified air. This is basically the interface of the software that you can access through your smartphone or through the laptop. So it will provide information about the air qualities, the threshold, the current level of the air qualities, the fan speed and how fast the fan is running, the halo usage times, how long you have implemented halo in the laboratory, the filter conditions, and then when is the time to change the filters. And you can also get all the events recorded in this software, so you have traceability. So when you on, when you're off, when there's an issue of fans, when there's detections of emissions, are all recorded inside this software. This is our case studies, the halo filtering systems we install in University Technology Petronas. So they have GCMS rooms equipped with 5 GCMS. The GCMS constantly emit chemical vapors into the room, and the air condition system that they use is basically a split aircon. As you know, split aircon do not introduce outside air into the room, therefore there's no air change in the room. Hence, halo systems have been proposed to be used in the room. So the room size is around 80 to 100 square meters. Therefore, we recommended 4 units of halo to increase the air change rate in the room to at least 4 or more air change per hour. This is how it looks like after the installations. The customers are delighted because after the installations, the air qualities of the room improve. Any fugitive emissions will be removed less than 20 minutes. And the customers can constantly monitor the air quality of the room. They can access through their smartphone even before they enter the room, so they can protect themselves from these fugitive emissions. To maintain the halo is very easy. The filters can last for at least 2 years. So the filter replacement can be done easily, like shows in these photos. You can get more information about halo system from our website, and our website is www.tms-lab.com. Thank you for your attention.